My name is Ashir Rajpoot and Siyaam.
My name is Siyaam.
And today the topic of our presentation is Hinge loss function. So the outlines of Hinge loss function that we will be discussing in this presentation is introduction, history of Hinge loss function, what is Hinge loss function, equation of Hinge loss function, real life example of Hinge loss function, and conclusion at the end. So what is the history of Hinge loss function? The Hinge loss function was developed to correct the hyperplane of SVM algorithm in the task of classifications.
SVM means singular vector. Yes, please.
Singular vector machine. So what is Hinge loss function? The loss function is the function that computes the distance between the current output of the algorithm and the expected output. The x-axis represents the distance from the boundary of any single instance, and the y-axis represents the loss size here. So all penalty that the function will incur dependent on its distance. What is Hinge loss function? There are few things that are to be noted here. That dotted line on the x-axis represents number 1. This means when an instance distance from boundary is greater than 1, that our loss is 0. When it is greater than 1, then our loss is 0. If the distance from the boundary is 0, meaning the instance is literally on the boundary, then incur the loss size is equal to 1. When it is equal to 0, then the loss size is 1. And when it is greater than 0, then the loss size is 0.
Yeah, my son, I really appreciate. First of all, clapping for Ashir and Siyaam. This is a difficult topic. Of course, they are trying their best. Please repeat again the dotted line. Here in the figure,
yes,
the dotted this point at some lower point. No, just at this point.
Yes,
see the x-axis and the y-axis. There is no height, so there is no difference. So our hinge loss size is 0. Are you getting my point?
Yes,
so
sir.
not a big gap. No gap means no loss. Difference, error, no error, least square error. Okay, loss is what? Basically kind of an error. Okay, so at the 0 position, please point to 0.
Yes, sir.
See the gap between 0 to the crossing. Okay, x-axis. So y-axis where the cross. This is 1. Okay.
Yeah, this is 1.
No.
This is 0 and this is y-axis.
Yeah. See at this point, no hinge loss. Hinge loss size is 0. At this point, this gap. This gap.
Yes, sir.
Yeah. Okay. Okay. Please carry on.
So we see that correctly classified points will have smaller or non-loss size, while incorrectly classified distance will have a high loss size. A negative distance from the boundary incurs a high hinge loss. That essentially means that we are on the wrong side of the boundary and that the instance will be classified incorrectly. The wrong side of the boundary is this on the left side.
The top of the line, you can see the hinge loss.
It will be the high hinge loss.
Yeah, the negative side. So
yes,
gap, see, from the x-axis, very big gap. Yes, it's good, great.
So on the flip side, a positive distance from the boundary incurs a low hinge loss. When we go on the positive side, then there will be only a very low hinge loss or no hinge loss. And all the further we away from the boundary and on the right side of it, the lower of our hinge loss will be. When we go on the right side, the hinge loss will be lower, and when we go on the negative side, the hinge loss will be high.
Okay.
So further, my partner Siyaam Khan will present.
Yeah, first a clap. I know you people never appreciate them because you people are a little jealous. Yeah. See here. This positive side, there is no gap below. Okay, no gap. So hinge loss is almost 0. But here, on left side, the gap is too much. Okay. So this is the reason. Please, Siyaam. Good.
Okay. Numerical visualization. This graph essentially strengthens the observation we made from the previous visualization. We can see that again when the inside distance is greater or equal to 1 from here to go. Our loss will be no loss. Okay. When the point is at the boundary, the hinge loss is 1. When our point at this point, that means our hinge loss is 1. And when the distance from the boundary is negative, from left side, we get an incrementally larger hinge loss. Non-real explanation of hinge loss. Now we examine the hinge loss for several predictions made by a hypothetical SVM mean super vector machine, and one key characteristic.
Singular vector machine. Yes. What is this? Could please some of you explain what is this?
Sir, it is a model in machine learning. It is about linear regression and classification.
Okay, good, great. I will study about it. We should study about it.
One key characteristic of SVM and the hinge loss is that boundaries separate negative and the positive instead as +1 and -1. With negative one being on the left side of the boundary and positive one being on the right. If we at index 0, if our actual value is 1 +1, if our predicted value will come 0.97, then hinge loss will be 0.33. We will minus from 0.97 from 1. And when we will have at index 1, actual value is 1, the predicted value will come 1.02. That we can say that we are on the correct side, and the hinge loss will be 0. And like that. And equation of hinge loss function. Hinge loss is actually quite simple to compute. The formula for loss is given by the following: L is equal to max 0, 1 minus y index and into x index minus b. Here L represents to the loss of any given instant, and y index and I is referring to the ith instance in the training set, and b referring to the bias term. This formula can be broken down in the following.
Yes, this is basically Siyaam was trying to explain nothing else except the formulae of a line. Okay, the gap from the main equation of line, or you can say incline the. Okay, I told you about the scale formulae. So if gap is bigger, then of course there is a big hinge loss. If the gap is smaller, then the low hinge loss. In this, the last he told us some kind of a detailed explanation. The zero hinge loss will become 0, mean that there is no loss. Replica and the actual product both are exactly same.
Yes,
Thus there is not a big difference. So loss is 0, mean the gap difference between two products. One is the replica copy thing, and other is the original thing. There is no no difference. That's why it's 0. In this situation, the hypothesis, this omega dot x basically is the hypothesis. Why? Okay, this can represent some kind of a hypothesis. Predicted value greater than or equivalent to 1. Okay?
Yes, sir.
If yes, please.
And further, this is our conclusion. Similarly, darting at first hinge loss and may seem like a terrifying concept to graphs. But I hope that I have enlightened you on the simple yet effective strategy that the hinge loss formula incorporates. I hope you have learned something new in this presentation.
Where is the application from daily life?
Oh, okay, sir. सर अगर हम की वैल्यू अगर कोई डिटेक्ट करना चाहे, फॉर एग्जांपल हमारे पास कोई मशीन है, मशीन में अगर किसी की अगर वैल्यू को प्रिडिक्ट करना है, फॉर एग्जांपल हम कैट की ले, अगर कैट की वैल्यू मशीन के सामने करते हैं तो उसकी कैट की वैल्यू हमारे पास एक्चुअल वैल्यू जो एक्सपेक्टेड वैल्यू जो होती है हमारे पास आ जाती है। अगर एक्चुअल वैल्यू 1 है, अगर हमारे पास कैट को उसके सामने लेकर जाते हैं और हमारी प्रिडिक्टेड वैल्यू क्या आ जाती है 0.97, यू कैन से दैट देयर इज नो लॉस. Some error will come, but we can say there is no loss. This is a real life example.
Yeah, actually problem is not this. I want to extend his example. For example, there is a tiger and there is a one cat. Both are having, basically tiger is also kind of a cat.
Yes,
Okay, so both have the 4 legs,
Yes.
big tail.
Yes.
Okay, you can say that somehow strips on the body, both. Okay,
Yes.
maybe if you are observing the black and white image of the tiger, you will see that tiger and cat almost look alike.
Cat, sir.
Yeah, yes, please. So the situation is this: you are giving some kind of a margin, and margin you are setting some kind of a threshold. Basically, color of the tiger is kind of a feature, one feature. Yellow is one feature. Cat color is the feature of the cat. Yellow color is the feature of the tiger. Otherwise, looks like, okay, some, if there is a big size of kite and the small paw of it, you can see the tiger, almost look alike. So there are the certain features, but there is only one feature of the color. Suppose, just for understanding, please, are you getting my state? You know, don't play with mobile. Okay, don't play with mobile. Yes, rest of the features: 4 legs, 1 big tail, 2 eyes, 2 ears. Similarly, like the hairy body or the walk. Okay, pedestrian. You can say that some kind of gait recognition. Gait means how look like they will walk. Okay, so almost are similar, but except one feature, that's the color feature. This value may be not exactly, so you can say that, so not same, but the small threshold, this is a margin, but still it's kind of a complicated thing, so I will try to explain, but I appreciate you, try to explain, but there is always a lot of improvement. Yes, sir. Okay, and you're clapping for both. One thing, if you are coming in a class and you do not understand this subject, I told you in start that this subject is